A tutorial for CE162P. Design of a strap footing. Presented by Bagasdas Wendell, De La Rosa Pauline Kim, Inducal James Ivan, and Mihino Kim. What is a strap footing? When the independent footings of two columns are connected by a beam, it is called a strap footing. It is used when the distance between the columns is so great that the combined trapezoidal footing becomes quite narrow with high bending moments. In this case, the column is provided with its independent footings and the beam is used to connect the two footings. The strap beam doesn't remain in contact with soil and thus doesn't transfer any pressure to the soil. The strap, assumed to be infinitely stiff, serves to transfer the column loads on the soil with equal and uniform soil pressure under both footings. Using example 3.4, let us try to determine the size of the footings A and B. Given columns A and B, where column A carries a live load of 40 kips, a dead load of 50 kips, and column B carries a live load of 80 kips and a dead load of 100 kips. The distance between these columns is 22 feet. The allowable soil-bearing capacity is 3,000 pounds per square foot. The depth of footing is 24 inches, and the depth of soil above footing is 12 inches. Determine the size of footings A and B. Let us follow the design procedures of determining the size of the footings. First, let us determine the length of exterior footing and its eccentricity E. Then, determine the eccentric moment M. Determine the shear force V. Determine footing reaction RA. And then determine footing sizes for both A and B. The factored loads are then calculated by multiplying the dead load with 1.2 and multiplying the live load with 1.6. For column A, the factored load is equal to 138 kips. And for column B, the factored load is equal to 276 kips. The positive critical moment and shear were calculated. Mu is equal to 276 kips feet and shear is equal to 13.8 kips. This is the load diagram, shear diagram, and moment diagram due to the loads carried by the columns. The effective depth D due to punching shear is equal to 2.1 inches. Using a strength reduction factor of 0.9, Mn is calculated. Mn is equal to Mu over Phi. Mn is equal to 306.67 kips feet. For the example, Rhomen is equal to 0.0033. The total area of steel is calculated as 192.43 square inches. Therefore, 5 7-inches diameter bars are used as main reinforcement. The temperature bars are 4 inches diameter bars and has a spacing of 10 inches.